Welcome to the first lecture of chemical thermodynamics. So in this semester we will try to see the chemical thermodynamics, electrochemistry and chemical kinetics part. Okay. So basically the thermodynamic parts and electrochemistry part, some introductory aspect has been like introduced in the same one and same two of the 5 years. So we will try to extrapolate that knowledge of thermodynamics as well as other topics related with the physical chemistry to the higher level. Okay, so basically we are going to deal with the three topics in the core physical chemistry, that is thermodynamics, electrochemistry and chemical kinetics. So first we will start with the chemical thermodynamics. So chemical kinetics and chemical thermodynamics are the, we can say that, main two branches of the physical chemistry. So generally we will dealing with chemical reactions in the chemistry. So we need to study that chemical reactions. So there are ideally two ways where we can study the chemical reaction. Okay, so this chemical thermodynamics and another is chemical kinetics. Okay, so there are two branches of chemistry. So out of these two branches, this chemical thermodynamics or the thermodynamic branch is dealing with the macroscopic particles. Okay, macroscopic means large amount of particles, and these macroscopic particles are generally gives you the energy change. Okay, energy change that is occurring in the given system. So this is the broader concept. So if you want to have the knowledge of bulk system, we can apply these thermodynamic laws to the macroscopic system, and from that we can get the various energy changes that has been occurring in the given system. Okay, so that is the one aspect for the given reaction. Now another aspect is how much that reaction is occurring. Okay, so if we want to like consider the reaction in terms of time, that we have to consider the kinetics part. Okay, so this whole chemistry can be subdivided into two parts. One is thermodynamics and another one is the kinetics. So in thermodynamics, what we study, we generally study the energy changes that has been occurring into the given system, and for kinetics we will study the rate of given change. Okay, so we can broadly classify these two branches of physical chemistry likewise. So we will try to see in detail this thermodynamic in this chapter and the chemical kinetics in the another chapter. Okay, so we can say that here chemical thermodynamics is a branch of a physical chemistry which is related with the energy change. Okay, which is related with the energy change. So name of this chapter only suggests that thermo means what? Basically it is the heat energy, that is thermo, and dynamics means what? Motion. Okay, dynamics means the motion. So basically we can say that it is the study of heat motion. Okay, motion of heat. So this is the introduction of the chemical thermodynamics. So we can say that this thermodynamic is dealing with the motion of heat, simply motion of heat. Okay, so all the natural as well as artificial processes or the reaction which will take place by what? Either absorption of a heat or the emission of a heat or the redistribution of a heat energy. So energy can be having the form of either heat or radiations. Okay, so depending upon the type of radiation that are being involved, there might be the heat type of radiations or the heat type of energy and radiation or the electromagnetic radiations. So this energy is either absorbed by the given system, emitted by a given system, or the redistribution of the energy means just transfer of one form of energy to the another form of energy. So all of these changes could be studied with the help of this thermodynamic laws. Okay, so generally we will dealing with the heat energy. So heat energy is found to be in the most common, which is appears in the all the processes. Beside this, other form of energies are what? Electrical energy, chemical energy, or the light energy, that is radiation type of energy. So the energy which is stored in the all substances, and these will appears when the substance will undergoes a chemical change. Okay, so when there is a storage of energy, we can say that is the potential energy, which is inherently present in the all the substances. So when the substance will undergo certain chemical change, it will transfer its energy from one form to the another form. So basically we can say that this thermodynamic is the study of exchange of thermal energy and the other form of energy between system and surrounding. Okay, so these terms, that system and surrounding, that we are going to see later on. So all of these changes that has been occurring into the given system has been governed by certain laws. Okay, so there are the certain laws which are like arbitrarily they have been given. Okay, so there is no as such a valid proof for that laws. They have been just observed practically, and they have been established. So all of these changes has been governed by certain thermodynamics laws, which are applied to the chemical reaction under the name of chemical thermodynamics. So this chemical thermodynamics based upon, we can say that four laws are there. Okay, zeroth law, first law of thermodynamics, second law, and third law of thermodynamics. So there are in total, we can say that four laws are there which will govern all the thermodynamic processes. The nature of chemical processes and the kinetics, thermodynamics parameters such as rate constant, activation energy, heat of reaction, equilibrium constant, etc., which can be determined with the help of these laws. However, the rate of reaction, we have to use the another branch of chemistry, that is chemical kinetics. Okay, so thermodynamics will tells you only the energy change, but the rate of that energy change can be only been calculated by using chemical kinetics part. Okay, so thermodynamics cannot be applied to the microscopic system. So we have already seen these certain limitations of the thermodynamics. It can only be applied to the macroscopic, that is large particle systems. Still it is being very useful way of the study for the given system. So in introduction, we can say that this thermodynamics is useful for the study of energy change or the heat change that has been occurring into the given system. So energy can either be transferred in the form of heat energy or electrical energy, chemical energy, or the light energy. So we can have the detailed knowledge of various parameters related with the system, like rate constant, activation energy, heat of reaction, equilibrium constant, likewise. So we can obtain the knowledge of all of these parameters by using thermodynamics. Okay, so this thermodynamics containing the certain terms, like what do you mean by system, what do you mean by surroundings, what is the meaning of open system, what is the meaning of closed system, what is the meaning of this isolated system. So all of these terms are already known to us. So we will try to see that terms one by one. So the first term is what? System. Okay, so thermodynamic system is what? Thermodynamic system is the portion of a universe which are under thermodynamic study. Okay, so if we consider the any part of a universe which is under study, then we can simply say that it is being the system. So for example, this is the famous example, like cup of tea. Okay, so if we consider the cup of tea, then it will be the system for our example. Okay, so we can say that the cup of tea is the system, and the rest of surrounding, that is the rest part of the universe, is called as a surrounding. So what is the surrounding? The surrounding is the remaining portion of a universe apart from the system, which is called as a surrounding. So system and surrounding are separated by certain boundary. Okay, so the boundary can be real or boundary can be imaginary. So in this case where we are considering what, the cup of tea, so there is a boundary between system and surrounding, but there are the certain systems where the boundary may not be like a real one, it can be imaginary one also. So boundary can be real as well as imaginary. So boundary is what, so one point is system, another point is surrounding, and the another point is boundary. So boundary is the surface which is either real or imaginary, which will separate the system and surrounding. Okay, so all these things, that is system, surrounding and boundary, all this part is contained in the what, in the universe. So universe is a whole, within that we are having surrounding, within that we are boundary and given system. So based upon the uh, like exchange of energy or the matter, the systems are classified into the three types. So systems are classified on the basis of matter and energy. So the system, first system is open system. So what do you mean by open system? So the open system which would be able to exchange the matter as well as energy. Okay, so if we consider the cup place or tea place in the cup. Okay, so we can say that that system is open because the vapors, water vapors can be easily go outside the cup, as well as if we consider the heat energy or the vapors energy, steam energy, that also can be exchanged with the surrounding. So in the open system we can have the exchange of both matter, that is the water vapors, as well as heat energy with the surrounding. Now next is the closed system. So in closed system there is a exchange of only energy but not the matter. So if we consider the cup uh, which is having some close opening. Okay, so if we place some material on the top of the cup, so there is no exchange of vapors or the matter, but there is only exchange of energy. Okay, so that is the closed system. And the last type of system, which is the isolated one. So if we simply place the tea in the thermos, then there is neither exchange of matter as well as energy. So we can say that that system is being the isolated system. Okay, so here open system is, it can exchange the energy as well as matter. Then closed system is what, closed system is the one which can only exchange the energy and not the matter. And last is the isolated system, which can exchange which cannot exchange matter as well as energy. Okay, so this is the some introductory part of the thermodynamics that we have already seen during the our previous classes. Okay, or the previous standard. Now we will be mainly focusing upon the Helmholtz free energy and its various form and its application, and Gibbs free energy and its applications. Okay, so we will try to see that in the upcoming lectures. Okay.